Assalamualaikum warahmatullahi wabarakatuh and good day to all of the panels. My name is Wan Jaslan, Binti Wan Jaafar, and I am supervised by Dr. Rahimah, Binti Abdul Hamid. So my title for my bachelor's degree project is a surface topography study of the untreated and heat-treated zirconia dental crowns manufactured through CNC dental milling machines. The introduction of CAD/CAM milling systems in the dental field enables zirconia ceramics to be used as a standard material for dental restorations and simultaneously accelerating the process of creating the restorations. The untreated CNC mill restorations, however, exhibits moderate surface roughness due to the reflective deflection between the cutter and the workpiece during the milling process. Surface roughness is one of the main properties which is responsible for the microbial attractiveness of denture surface and has to be monitored in order to avoid any discomfort among the patients during use. Therefore, in this study, the surface roughness of the untreated and the heat-treated CNC mill zirconia restorations will be examined using SCM machine. So in the dentistry sector, there are many types of restoration as you can see in figure 1 and figure 2. Figure 1 shows us the bridge restorations and the figure 2 shows us the crowns restorations. For the problem statements, the surface roughness of the produced dental restoration are one of the important factors which is believed could contribute to the accumulation of microbial in the mouth during use. The first hypothesis of this study is there will be some scratch grooves and also scallop high effect which could be accounted on the untreated restorations. The dental subsequently, the dental crown would be heat treated in order to improve its surface texture, but the appropriate temperature is still unknown due to the lacking of literature. The second hypothesis of the study is there will be an improvement of the surface roughness of the dental crown after the heat treatment. Therefore, a study on the surface topography of the untreated and heat-treated dental crown restorations would be carried out using the SCM machines. Before we analyze the surface topography, a measurement of the surface roughness for both conditions would be executed using a suitable surface roughness tester. The measurement process could be challenging due to the complex geometrical of the dental restoration surface. The first objective of my study is to compare the surface topography of the untreated and heat-treated zirconia dental crown using the scanning electron microscope. The second one is to analyze the surface roughness of the untreated and heat-treated dental crown restorations using appropriate surface roughness tester. The first scope of my study is the zirconia crown specimen will be heated at 850 to 1050 degrees Celsius only during the heat treatment test. The second scope of my study is the number of crown replication is 3 due to the expensive zirconia blocks also during my heat treatment test. The third one is a CAD file of the dental crown will be directly used to fabricate the specimens. We will not scan a new crowns due to the limitation of a capable 3D scanner at FKP. The last scope of my study is the powder coat used is platinum during the sputtering process. For the literature review, according to Tamada and the others, microbial adhesion is enhanced with increasing surface roughness between 0.1 and 0.4 mm. At the other hand, Boland and the others also state that there are a cut-off value which the surface roughness will not influence bacterial adhesion is 0.2 mm. This is supported by Rashid, which confirmed that a rough material surface will accumulate more plaque during actual use. These findings have proven the importance to monitor the surface roughness of the fabricated dental restoration based on the literature. However, a study on the surface roughness of the CNC mill zirconia dental restoration is still lacking. Hamid and the others has examined the fabricated CNC mill restorations, but it was only limited to the untreated restoration, not for the heat-treated restorations. The fabricated dental restorations would be heat treated in the present work in order to improve the surface accuracy, and a comparison of the heat treated and untreated CNC mill restoration would be executed. Hamid also has demonstrated the existence of a scalar high effect as shown in the figure 3, which is we can see the image that captured by the SCM machine. In addition, they also observe a micropitting as shown in the figure 4 as a result. The selection of the right surface roughness tester is also significant. This is necessary in avoidance of the incorrect data measurement. This is supported by Shahir, which highlighted that the RA values depend on the stylus location of the profilometer as illustrated in the figure 5. So for the next literature review, based on the Camilla and the others, the YTGP was used for dental restorations, and the specimen was polished, sintered, and inspected with digital caliper for the surface roughness. And after that, the specimen was undergone for the grinding process. And after that, the specimen was heat treated with the experimental parameter, which is they use 65 degrees Celsius per minute for heat rate and 1050 degrees Celsius for the final temperature. And after that, the specimen was coated with the gold sputtered. And lastly, the specimen is going to the SEM machine, which is for the topography analysis, as you can see in the figure 6 and figure 7. So for my methodology, as you can see for my flowchart, which is you can see my project was started with the 3D virtual model in CAD and then generate the STL file, continued with the milling process of the zirconia dental crown, and then after that we fabricated the part which is truss specimen of the crowns, and then continue with the several tests, which is at first test heat treatment, second surface roughness test, and lastly microstructure analysis. So firstly, for the dental crown specimen, which is the sample preparation, we decided to fabricate 12 samples of crown restorations. After the crown restoration, the 3 of them will be directly conducted for the surface treatment test, and the other 9 samples will be conducted for the heat treatment test, and followed by surface roughness test, sputter code, and lastly the microstructure analysis using the SEM. As you can see in figure 8, this is the sample of crowns fabricated from zirconia block, which is also going to be fabricated during my study. Next, we move to the zirconia dental restoration milling process. As you can see in the figure 9, this is the Adenta 3D milling machines that we will use during my study in fabricated 12 sample of dental crown restorations. During this process, the work material that used for this process is NETS ZLT, which is we obtain from Sage Matte Bioceramics. So for your information, after we purchasing these zirconia blocks, as shown in the figure 10, the Sage Matte Bioceramic give us a few samples of that file for the crowns and bridge restorations. So we just need to select one of the sample that provided for us from for my study. Okay, next we move to the heat treatment test, which is carried out using the machine that provided at FKP lab. So this heat treatment test was conducted after the mill dental crown restorations. So we decided to use 3 different final temperature, which is the first temperature is 850, the second 950, and the last one is 1050 degrees Celsius. So each of these final temperature will be tested by 3 samples, which is for the first replication, and then 3 samples for second replication, and then 3 samples for the third replication, as you can see the flow chart at the bottom of my slide. We use 3 replication because to avoid the human error during conducting this heat treatment test. For the machine parameter setting, according to Anna, they also study about the heat treatment for the zirconia restoration. So we use their parameter setting during my study, which is standby temperature at 403 degree, heating rate at 50 degree per minute, and also the vacuum in and vacuum out setting. So after we finish the heat treatment test, all of the specimen, which is 12 sample, will conducted for surface roughness test. This test was conducted using the Meteoto Surface SJ410 provided by FKP Lab. Before we starting the test, we need to performing the calibration process, which is we adjusted the detector gain so the SJ410 can yield the correct measurement. The roughness characteristic measure is arithmetic average. which is arithmetic means of absolute values of the roughness profile ordinates. Then the specified points will be selected at the buccal and the lingual at each specimen. So we decide to select 4 points at each side of specimen, as you can see in the figure 14. The measurement areas that had been selected is in consideration with the limitation of the surface roughness tester, which is could only read the flat surface. In this context, the measurement need to be repeated 3 times at each selected point to get the average measurement because there will be human error and error during use the roughness tester if we just take one measurement only at each point. The occlusal surface was not examined due to the complicated geometric surface profile on the crown. So after that, we're going to the sputtering process that will be conducted after the roughness test. All of the sample need to be coated with platinum using the mini sputter coat provided by FKP. This process required in the field of electron microscopy to enable or improve the imaging of the samples. And for the last process, which is the surface topography analysis, we conducted and analyzed this test using the SEM machine that provided by FKP Lab. The topography or the surface texture of the heat-treated crown, which is 9 specimens, and the untreated crown, which is 3 samples or 3 specimens, will be analyzed under the SEM machine. For the SEM parameter setting, we decided to capture the image of the surface with 3 images of magnification. The first one is 100 power magnification, second is 200, and the third one is 300 power of magnification, as you can see in the table. So for our expectation, the heat treatment experimentation will reduce the scallop high effect on the crown surface. Lastly, the comparison between the heat treated and the untreated dental restorations will be successfully carried out. In conclusion, the tooth path and the size of the cutter during the dental milling restoration will produce the scallop high effect and scratch grooves on the surface due to the geometric feature on the crown surface. We will propose the suitable temperature for the heat treatment and procedure for the test. This study will show the heat treatment temperature plays a significant role towards the surface roughness and prove the heat treatment could improve the surface roughness of the dental restorations. Upon completion of the study, the surface topography of the heat-treated and untreated dental restoration will be carried out using the suggestion method. At the end of the study, will be support the hypothesis through the SEM machine as our result. So that's all from me. Thank you for your concern. Thank you for to all the panels.